lots of new products are released. Between summit to summit, lots of new products. One of them is what we're calling a what-if assist. Now, it's a pre-packaged set of charts to help you answer what are called what-if questions. So the chart actually moves around as you decide to change some numbers and gives you an answer. And so I can't show it to you. I'd rather you see it to see what it's all about. And this is also used inside of what's called prescriptive analytical applications. Now, as you know, there are 4 kinds of applications that we speak about. One is, what's the first one? Well, you tell me, what's the first one? Descriptive analytics, which tells you what's happening. Diagnostic analytics tells you why it happened. Predictive analytics tells you what might happen in the future. But the most important is prescriptive analytics, which tells you what to do about it. And so I'd like to bring out Porter Thorndike. Porter, you all probably know Porter. He's going to give you a demonstration of our new what-if analytics. Nice to have you.
Legend, Jerry Cohen, the legend.
Oh, Porter.
I'm inspired every day to come to work with you, sir.
That's what inspiration does. You get very
Let
tall.
me show you how we support what-if analysis in prescriptive analytics. The first demo is break-even analysis. This is part of a product portfolio we have called Comprehensive Goal-Based Visual Analytics. In break-even analysis, we'll look at things like fixed operating expenses, the variable cost to produce your products, the variable revenue received for the sale of those products, and it will tell you at what number of units sold you will break even. So for these, we're using comprehensive bottom-up methodology. That is superior to top-down methodology, which just says, what does my revenue need to be to achieve a certain profit? Comprehensive bottom-up methodology will take into account the practical limits of your root and calculated variables. It will allow you to set goals, and it will tell you, are those goals realistic? And if they're not, what's the best that I can expect, and what relaxation of the root variables is necessary to achieve my goals. So you can do all sorts of what-if analysis with the root or calculated variables, and you can set goals. So if I want my break-even units to go from 9,000 to 4,000, could I accomplish that through an increase in the price alone? And if we look at the price, you could. I mean, boy, would we be gouging our customers, jacking it up to $32, but we could do it. Could I do it through a reduction in the cost alone? And this is where it will tell you if it's outside of the practical limits of your root variables. And there's all sorts of other what-if scenarios we can do, like what would happen if my operating expenses went from 90,000 to 110,000? What would happen to my bottom line? Naturally, our profit goes down, and our break-even units actually goes from 9,000 to 11,000. So what can I do to get it back to 9,000? Could I get it back to 9,000 through an adjustment to the price and the cost? And I could, just a modest increase in the price, modest reduction in the unit cost. I could get back to that goal. What if I want to go crazy, get really aggressive here? Can I get it to 5,000? Could I get it to 5,000 through a reduction in cost alone? It's going to tell us it's outside of the realistic and practical limits of that root variable. But I've got other options. There are other root variables at play that calculate break-even analysis. Like, what if I was able to reduce my fixed expenses, like selling expense, R&D, and overhead? Could a combination of those two get me to my goal of 5,000 units? And it could. You'd have to get your operating expenses down to 75,000 and really produce that product at a low cost, but you could get there. So we've got a variety and a suite of these products that will allow you to do this what-if analysis, and you can build them graphically in InfoAssist. Jerry, do you like that?
I think it's great. And
do you guys like that?
Wait till you see all the other great graphs we have that allow you to do analytics right there on the graphs as they move around and help you decide what, it's called the what-if process.
They are amazing, Jerry, absolutely.
But Porter, let me ask you a question. What if I had a larger scale system? For example, I want to do some type of, this is all prescriptive analytics. It's telling you what could happen. How do I get to something? What if I had several products I wanted to do this?
Jerry, we have the perfect solution for that. As you know, many of you have challenges that may go beyond what these could solve. That could be data related, maybe predictive model related, interface related. What's better at solving those challenges than an info app, Jerry?
Well, let's see one.
Okay. So this info app is going to use prescriptive analytics, looking at price elasticity and price optimization to tell you exactly where you should price some key products of yours. And we're using an info app to do this. So prescriptive analytics is the holy grail of analytics. It builds on descriptive analytics, and you can think of that as the current report right here that is telling us 5 key products, where they're priced, and the historical sales. Predictive analytics will go further, and as you know, we have an RStat product that will graphically build a model using input variables of things like the historical sales, competitor price, product segment, customer segment, and will allow you to do great what-if analysis to see what the model will predict at different prices your sales will be. So let's do that. Let's run a simulation. What does the model think a slight increase in the prices of these products will do? I've got some graphs to help us understand this. The diamond is the actual, and the bar is the predicted. The model hates a price increase, predicting a decrease in units sold and sales and margin. What does the model think about a slight decrease in the price of these products? And we can just mix and match, do any sort of combination with these sliders. The model loves a price decrease, okay? But I'm just kind of guessing here with the sliders. This is where prescriptive analytics can help. Prescriptive analytics will build on the model and the knowledge of the predictive model, which is typically just looking at structured data, categories and numbers. Many prescriptive models will add unstructured inputs like video, audio, images, text, and it will use the predictive modeling techniques that we build graphically with RStat and combine optimization techniques that could include machine learning, artificial intelligence, and natural language processing. And prescriptive analytics will tell me exactly where I should price those products and the optimized price. So if I click prescribe, we're going to run the prescriptive model, and we see exactly where we should price those products. And it's recommending between 87 to 94% of the original price. Modest price reduction is what gets our optimized number of units sold, sales, and margin. Jerry, do you like that also?
I think that's great. Now, you might ask the question, though, well, how do I predict what the volume will go up if I lower the prices? Well, companies are doing that all the time. You recognize when someone has a sale, they reduce their prices, and then they measure what the volume has been. So that's one way of doing that. I guarantee you, all of the airlines, when they started to increase prices, were worried also about what the competitive airlines were doing. This all can be modeled and be put into some kind of predictive model, for example, that people can manipulate and get great ideas out of. And something that you can do, it's all the technologies right there. This is just an info app, right?
That's right, Jerry.
But the numbers underneath is an RStat prediction. So when he changes price, it says, well, here's what I think the volume would be with perhaps other variables. You see, so it's a can be a very realistic way of simulating a whole process. Thank you, Porter.
You're welcome, Jerry.